Hi everyone. In your previous session, we have discussed about dielectric material and why we are going to consider any material as a dielectric material. In the coming session, we can discuss about the different types of dielectric materials. Usually, we are going to classify our dielectric materials in two ways. One is a polar dielectric and another one is non-polar dielectrics. Now, we can discuss in detail about polar dielectrics and non-polar dielectrics. What do you mean by polar dielectrics and what do you mean by non-polar dielectrics? First, we try to speak about a polar dielectric material and what it means. Polar dielectric materials are materials which are consist of molecules that have a permanent dipole moment. Because of this permanent dipole moment, we can expect the asymmetric charge distribution within the molecules. Even in the absence of external electric field, these dipoles exist, but these dipoles are not oriented in a good order, right? These dipoles are usually oriented randomly. This random orientation does not give rise to any net polarization. So, when an electric field is applied, the dipoles align in the field direction, then we can observe the resultant polarization or we can expect the polarization. Until and unless the application of electric field, we cannot observe any polarization in case of polar dielectric materials. Even they have a permanent dielectric dipole. Right, why we are going to expect the permanent dipoles? The permanent dipoles are due to a molecular asymmetry and the align with the electric field to enhance the polarization. If they orient or if they line up with electric field, we can expect the improvisation of polarization, and they show the temperature dependent behavior because thermal energy disturb dipole alignment. And various examples we can see for our polar dipoles, polar dielectric materials. The best example is our water. Water is a classic example of polar molecule with a bent structure causing the dipoles. And another example is HCl. Here the significant electronegativity difference between hydrogen and chlorine which makes polar. And also we can consider one more entity, that is ammonia. Ammonia is also a best example for polar dielectric materials, right? Due to its pyramidal shape, it has a permanent dipole moment. And also we can concentrate about non-polar dielectric materials. A slight deviation from your polar dielectric materials here. How can we define non-polar dielectric substances? Usually, in this case, we are not supposed to observe any permanent dipoles as polar dielectric materials. Therefore, we can define non-polar dielectric materials which consist of molecules that do not have a permanent dipoles. Due to the lack of permanent dipoles, we can expect the charge distribution is in symmetric way, and any induced dipole is due to the distortion of the electron in the presence of an electric field. And what are the key characteristics of a dielectric material of your non-polar kind, they have no permanent dipoles, only temporary dipoles which are induced by the external field only. Here the polarization occurs basically through electron distortion, and a temperature has little impact on polarization since no alignment of dipoles is involved, because which have a lack of permanent dipoles. And here some examples of non-polar also: a symmetric diatomic molecule with no permanent dipole moment, that is the best example is nitrogen. Similarly, oxygen also have no non-symmetric structure, therefore the symmetric diatomic molecule of your oxygen is also an example for non-polar dielectric substance. And benzene also, a planar molecule with symmetric charge distribution, we are going to consider benzene is also a non-polar substance. Polyethylene also best example for non-polar dielectric substance, because a common polymer which is used in electrical insulation. And some common dielectric materials in general: ceramics, most of the ceramics are best example for dielectric material which have a high permittivity and also used in capacitors. Polymers are also examples for dielectric materials. They have a high flexibility and used in cable insulation, so using a material called as Teflon and polyethylene. Mica is also a best example for dielectric material which have a high thermal stability and also used in capacitor and as electrical insulator. The best natural example, natural dielectric material right in the universe, that is called as air. Air is the best example for dielectric material. Glass is also a best example for dielectric material because which have a high breakdown strength and stability. And where is the place of application for the dielectric materials? We can use these dielectric materials abundantly in the manufacturing of capacitors, because dielectric material have a tendency to store the energy in an electric field, and also in insulators, because which prevents the unwanted current flow in the circuits, and transmission lines. The purpose of utilization of dielectric materials in the transmission line is to reduce the energy loss and signal degradation. And very important application of your dielectric material is used in piezoelectric devices, because certain dielectrics generates electric charge under mechanical stress. Therefore, these piezoelectric devices can be used as a transducers. With these brief information, I would like to conclude this session.